Primitive unit cells are the one which has atoms only in the corners, right? So we'll discuss about the number of atoms for the primitive unit cells, centered unit cells. In centered we have three types. We'll discuss the number of atoms for all these things. So let's start with the primitive. So in the primitive, what we have seen, the atoms are there only on the corners, right? Atoms or molecules or ions, depending on the structure we're looking for, or the constituent particles. Now they are only at the corners. So if you see, this is my first structure. This is called open structure. So this structure is just to understand. But if you see, this particular atom will be shared by 8 other lattice, 8 other unit cells, because there will be one unit cell here and 2 more in the front and 4 more in the up. Correct? Example, this is my lattice. Correct? So I can have one here. Correct? And I can have 2 more here on the front, and then I can have similarly the 4 on the top. So 4 on the top, 1 here and 2 in the front. So that way they are totally, this particular one which I am talking about is shared by 8. So if you see, this has only 1/8 contribution. So 1/8 of the sphere will be part of this unit cell. Correct. So this structure is more of an open structure, just to understand, but this is not the actual structure, because actually when you talk about 2 atoms or 2 molecules, they are almost touching each other. They almost touch, right? In fact, there is an overlap. There is overlap because it's all electron clouds we have discussed in quantum. This is just a representation. This is not the actual representation. This is not how a unit cell will look like when you see a real, let's suppose, sodium chloride, a real crystal using X-ray diffraction. So in that case, everything will be overlapping. It will be overlapping. It won't be a spherical shape also. It is just to understand. This is my just open structure, not an actual structure. This is more, it depicts a space filling representation, right? Because if you see here, it actually shows that this is same, but with this you're not able to make out how it is, right? So this is more to understand how it is arranged, but this is actually, it tells, okay, no, these atoms are all touching each other, and this is how the space are filled. This is more of a space filling structure. Correct? And this is the actual portion of unit cell, because this unit cell, if you see this particular example atom I'm talking about, this is shared by 8 other unit cells. I just showed you, this is one unit cell, there will be one unit cell here, 2 in the front and 4 in the top. So this particular atom will be shared by 8 unit cells. So per contribution is 1/8, and 1/8 of the sphere is shown here. This is the actual portion of the unit cell. Now if you see in this, there are how many cells or how many atoms? 1, 2, 3, 4, 5, 6, 7, 8. Here also 8, right? There are 8 atoms. But per atom contribution is how much? 1/8. Correct? Because per atom is shared with 8 other unit cells. So this is I am talking about for a unit cell. For a unit cell, number of atoms is equal to total number of atoms 8, and per atom is shared by 8, so it is 1/8, right? Because if you see, 1/8 of the sphere is only here, so you say 1/8 into 8, total is how much? 1. So there is only one atom actually in this unit cell. This is nothing but one atom. Looks weird, right? So if you visualize it clearly, if you think little bit, you'll see that This is nothing but one atom. So what we have done is we broke this one atom into 8 parts and you just stick it in the 8 different corners. You'll get this figure. You can try this with one spherical fruit. One spherical fruit you can take, spherical potato and try that. So this is how it is. The next is my body center. So let's see how many atoms are there in the body center. Here also the first figure, if you see, is the open structure. Why? This is just to show how it looks. The next is more of a space filling structure. So in this, you see, again here, if you see 1, 2, 3, 4, 5, 6, 7, 8, 9 atoms, here also you will see 9 atoms. 1, 2, 3, 4, 5, 6, 7, 8. Sorry. One is hidden actually. That's why we do the structure, so that you can see actually, you can visualize it. There is one extra atom which is hidden, not seen. So there are 9 atoms. But out of these 9 atoms, are all these 9 atoms contributing totally to this unit cell? No. So let's draw the actual contribution. So this is unit cell portion, actual belonging to it, right? This is unit cell portion. So now in this, if you see, all these corner atoms, they are shared by 8 other atoms, 8 other unit cells, similar to the last one we have seen. So their contribution will be what? They are 8 into 1 by 8. And this one in the center, the body center, is totally owned by this unit cell. Nobody is sharing this. Plus 1. So total is 2. So there are 2 atoms in this unit cell. So there are 2 atoms per unit cell. Unit cell in case of body centered closed package. Hope you understood why. So in case of the normal cubic packing, we saw that there were 8 atoms in the corner and each atoms contributed 1 by 8 to this unit cell. Total contribution was only one atom per unit cell. So in this case, there is also one atom in the center of the body, and that is not shared by anyone. Total is 8 into 1 by 8. There is this 1 by 8 add to 1 is hidden, which is not seen, and 1 in the center you added, you get 2 atoms per unit cell. Correct. The next is face centered. So face centered also, if you see, this is my open structure. This is more to visualize how it looks, right? And the next is the space filling structure. So if you see here, you can see all the atoms 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. In this you can't see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 2 are hidden. And that's why we have this open structure, just to make you understand how it looks. This is the space filling structure. But here we want to know how many atoms are there actually in a particular unit cell. So this is nothing but a structure which depicts the unit cell portion. Unit cell portion belonging of atoms belonging to it actually. Okay, so now if you see in this case, these ones, the one on the corners, are shared by 8, right? They are 1, 2, 3, 4, 5, 6, 7. There are 8 such atoms shared by 8, 1 by 8 done. Plus, now there are 1, 2, 3, 4, 5, 6 on the face, but each of these is shared by 2. If you see, I have just drawn the half. Half is not even drawn, just for simplicity, right? So each is shared by 2. So 1 by 2. You add this, you get 1 plus 3, 4. That is, it has 4 atoms in a unit cell. So there is a difference. In the first case, the cubic one, there was only 1 atom in the unit cell. The body center, there were 2 atoms in the unit cell. And in this kind of packing, they are able to manage 4 atoms in a unit cell. Correct. The next is end centered. So in end centered also we have same thing. So this is, again, I'll just make it clearly. So in this case, the number of atoms in unit cell will be much. 1, 2, 3, 4, 8 on the corners, each contributing 1 by 8, plus 2 on the face, and each contributing 1 by 2. So if you see, this is nothing but a half sphere. Total is how much? 1 plus 1, that is 2. So there are 2 atoms in a unit cell in case of end-centered. Please remember, this is pretty critical for solving numericals. In case of normal cubes, we have only one atom per unit cell. In case of body-centered, 2 atoms per unit cell. In case of face-centered, 4 atoms per unit cell. In case of end-centered, 2 atoms per unit cell. You don't need to remember. Actually, if you remember the figure, you can very well calculate on the spot in seconds. You don't need to remember things. Just remember the figure. Remember the figure. I think the video must have made your concepts clear. If you remember that, you can just calculate the number on the spot. Let's take some numerical now. So the question is, what is the significance of lattice point? So if you see, I took a unit cell. So lattice point, each lattice point represents constituent particles. These are all lattice points, right? So each lattice point is nothing but it represents my constituent particles. And my constituent particles can be what? It can be atom, it can be ions, it can be molecules. Correct. The next question is, name the parameters that characterize unit cells. I told that a unit cell has parameter A, B and C, that is the length of the edges, and alpha, beta, gamma, that is the angle. So these are the ones which actually characterize the unit cell, the shape of the unit cell. And then we have different kind of packing, that's different things altogether. But based on A, B, C and alpha, beta, gamma, we have 7 different kinds of unit cells. Monoclinic, hexagonal, we have seen that. Right, tetrahedral. So that is my parameters which characterize a unit cell. The next is, people distinguish between hexagonal and monoclinic unit cell. So let's first draw hexagonal and monoclinic unit cell. Correct. This is my hexagonal. This is monoclinic. So in monoclinic, if you see, all the sides are mentioned. That is, all the sides. None of the sides are equal. A is not equal to B is not equal to C. Correct. Talk about angle. We know that alpha and beta is 90 degree. 2 angles are 90 degree. And gamma I am not very sure. Gamma is something I am not very sure. It is not equal to 120 degree for sure. It can be any angle but not 120 degree. But in case of hexagonal, the pink one is the actual hexagonal actually. The pink one is the hexagonal. Here we have a lot of restrictions. Right? The restrictions are because it has to form this kind of hexagon structure. There are restrictions. So here A is equal to B but not C. So 2 sides are equal. And this is also, you can say, this is side B, but both are equal. A is equal to B. And about the angle, they say that alpha is equal to beta is equal to 90 and gamma is equal to 120 degree. So this is the difference. So if you see, in both cases, alpha and beta angle are 90 degree. Right? In this case, gamma is equal to 120 degree. In this case, we see that gamma can be anything but not 120 degree. Correct? And what about the sides? In monoclinic, all the sides are unequal. In hexagon, 2 sides are equal. The next question was difference between face centered and end centered. So we have this 2 diagram. This is my face centered and this is my end centered. Correct? So if you see the face centered, you have atoms in all the face, and you have how many atoms per unit cell? We have calculated 1, 2, 3, 4, 5, 6. 6 into 1 by 2, it is 3 plus 1, 4. So we have 4 atoms per unit cell. Here you have 1 plus 1, 2 atoms per unit cell. Correct? So that is the difference. The question is, how much portion of an atom located at the corner and the body center of a cubic unit cell is part of its neighboring cell? So this is my body centered one. The question is, this is shared by how many? We have discussed that this is shared by 8, and this is shared by the one in the center is shared by how many? None. Only by a single. So for this, the contribution is 1 by 8. The one in the corners, right? The actual contribution is only 1 by 8. And for the bodies, the one in